All right, here in the merge sort class, we need to add a new method, public void sort. We give it an integer array just like before. Now in this method, there are a few things we need to do. First, we need to divide this array into half. Then we need to sort each half. So we're going to recursively call this method, and then we're going to merge the results. Let's focus on the first task. So first, we need to find the index of the middle element in this array. That is super easy. So we set middle to array.length divided by 2. Now we allocate a new array that is going to be our left partition. So left, we set it to a new integer array with size set to middle. Now we need to copy all the items in the input array up to this point in the left partition. So for var I, we set it to 0. As long as it's less than middle, we increment it. Here we set left of I to array of I. Super simple, right? Now we need to create the right partition as well. So we declare another integer array. We call it right and set it to a new int. Now the size of this array is going to be array.length minus middle. Now we need to copy all the items that belong to this partition in this partition. So we set I to the middle index. We start from here. As long as I is less than array.length, we increment it. And here we set right of I minus middle to array of I. So we iterate over our input array starting from the middle point, but we need this expression here to copy these items at the right index in the right partition. For example, if middle is 4, we don't want to copy the item at index 4 of this array to index 4 of the right partition. That's going to be the first element in this partition. So with this expression, I minus middle, we can calculate the correct index, okay? So this was our first task. We divided this array into half. Now we need to sort each half. That is super easy. We recursively call this method. So we call sort and give it the left partition. And one more time, give it the right partition. We're done here. Finally, we need to merge the result. So we need to declare another method for merging two arrays. Let's do that real quick. So private void merge. What parameters do we need here? We need the left and right partitions, as well as the input array where we're going to store the result. So integer array left, integer array right, and integer array result. Now here we need to iterate over the left and right partitions. We read one item at a time. We pick the smaller one and store it in the result array. So here we need 3 pointers or 3 counter variables. I, we set it to 0. J, we set it to 0. And K, we set it to 0 as well. We use I to iterate over the left partition. We use J to iterate over the right partition. And K to iterate over the result array. Now here we need a while loop. While I is less than left.length and J is less than right.length. So with I and J, we read one item at a time from each array. Now we need to find the smaller value and store it in the result array. That is super easy. So if left of I, if the item that we're currently reading from the left partition is less than or equal to right of J, we're going to store this item in the result array. So we set result of K++ to left of I++. What's going on here? Well, for a second, let's not worry about the increment operators. So we're copying the item at index I of the left partition to index K of the result array. Now, after this step, we need to increment I. So next time, we read the next item from the left partition. By the same token, we need to increment K, so we store the next value in the correct position in the result array, okay? Now, if this condition is not true, that means we should copy the current item in the right partition into the result array. So else we set result of k++ to right of j++. So with this while loop, we iterate over both the left and right partitions. In each step of the iteration, we pick the smaller value and store it in the result array, okay? Now, it is possible that one of these partitions is smaller than the other one. For example, our left partition might only have 3 items, but the right partition might have 30 items. So this loop is going to terminate before we iterate over all the items in the right partition. So after this loop, we need to iterate over the right or the left partition, depending on which one is bigger, and copy the remaining items into our result array. So we need another while loop. While I is less than left the length, we copy the remaining items in the left partition into the result array. So result of k++, we set this to left of I++. We need another similar loop to copy the remaining items in the right partition. So while j is less than right the length, we set result of k++ to right of j++. That's all we have to do. So this is our merge method. Now back to our sort method. After we're done sorting the left and right partitions, we need to merge the result. So we call merge, give it the left and right partitions as well as the input array. So with this method, we're going to recursively sort the left and right partitions and then merge the result. Now, whenever we have a recursive method, we need a base condition, and we use that to terminate the recursion. So before we do any of this, we should implement our base condition. What is our base condition here? In other words, at what point should we stop the recursion? We should do that when we have an array with a single item, because an array with a single item is already sorted. So we don't need to break it into half, sort it, and merge the result. So if array, the length, is less than 2, which means it has a single item or no items, then we're going to return. So we stop the recursion here. Now let's test our implementation. So in the main class, let's replace insertion sort with merge sort and run our program. Our array is sorted beautifully. Now, what if we have, let's say, 2 numbers? It's still working. What if we have a single number? And finally, what if we have an empty array? Beautiful. So this is how we implement merge sort.